All right, this lesson is on absolute value, and absolute value of a number is the distance, is its distance from zero on the number line. And that's when we use the two little lines in that we read as the absolute value of x. So the question is, how many numbers have an absolute value of 3? Well, if you look at the number line, you look at 0, 1, 2, 3. The number 3 has an absolute value of 3. But if you go this way, -1, -2, -3, this distance is also 3. So -3 also has an absolute value of 3. So that's the concept. Anything that has that particular distance from 0 has that absolute value or that absolute distance. All right, this problem is asking us to evaluate using y equals -3, this expression that has an absolute value. Now, in terms of PEMDAS, you're going to treat absolute value bars as groups. Okay? So you have to do what's inside the absolute value bars first. So the first thing we do is we substitute in. So we have 1.4 plus the absolute value of 5 times -3 minus 7. And we multiply before we subtract, so we have 1.4 plus the absolute value of -15 minus 7. We're still working with the absolute value bar. And you get a -22. And what's the absolute value of -22? Notice that I'm keeping my plus sign. Is a positive 22. So your answer is going to be 23.4. Questions? All right, we can have the case of equations, and what happens here is that there's two situations with this equation. This absolute value bar can be equal to a 5. What's inside here is going to be equal to a 5, or it can also be equal to a -5, because the absolute or the value of -5 is also a 5. So the inside can be equal to a +5, or it can also be equal to a -5, because when you take the absolute value, you're going to get that +5. So what you're going to do is you're going to write both situations. You're going to say this x minus 18 can be equal to a 5, and, or the x minus 18 can be equal to a -5. And then you're going to solve each of them individually. So we're going to add 18 to both sides here. And you're going to get that x equals 23. Or we can drop these parentheses because there's nothing in front. And so we have x minus 18 equals -5. We're going to add 18. And you're going to get that x equals 13. And what you have to do now is you need to check. Must check. Almost like a mandatory. Because you can have the case where you'll only get one solution instead of two. Like you'll get an answer, but when you plug it back in, it won't work. And if you tell me that that's the answer, and it's not really an answer, then you're going to be wrong. So what you do is you plug it back in. So you plug in the x equals 23 into this equation. So you say 23 minus 18, absolute value, does that equal 5? And when you do 23 minus 18, indeed, you get the absolute value of 5. The absolute value of 5 is 5. So yes, this one checks out. And we're going to plug this one in over here. Absolute value of 13 minus 18, does that equal 5? Well, 13 minus 18 is -5. And the absolute value of -5 is 5, so 5 does equal 5. This one also checks out. Both of them are a solution. So both of them are the answer, 13 and 23. All right, with this example, what we have is the case of no solution, where no solution would be the answer. And so we have the absolute value of 5x minus 6 plus 9 equals 8. You want to definitely move this 9 over. and you get that the absolute value of 5x minus 6 equals negative 1. Well, this is impossible. The absolute value is always going to be a positive number. And this is saying that this absolute value has to equal negative 1. So this is a case of no solution. No solution is what you would put as an answer. All right, this is an example of a case where you're only going to get one solution. And this is what I mean by you have to check it, okay? So now that we have the absolute value equals, but it equals all of this, right? Now remember, this inside can be positive or it can be negative. So then you're going to say the case 1 would be when x plus 6 is equal to a positive 3x minus 2, or when x plus 6 is equal to negative 3x minus 2, right? Now this is an understood one, so you can just drop the parentheses. So this is x plus 6 equals 3x minus 2. This is an understood negative 1. So this becomes negative 3x plus 2. You have to distribute it in. All right, working with this, we have to get the x's on the same side. So I would do minus 3x, minus 3x. So we have minus 2x plus 6 equals negative 2. I'm going to subtract 6. We have minus 2x equals negative 8, and I'm going to divide by negative 2. X is equal to 4. Right? That's the first solution. And I'm going to go ahead and get this solution so that I can erase and we can work on plugging it back in and seeing what we get, okay? So with this one, I'm going to bring over this one to this side. So now I have 4x plus 6 equals 2. I'm going to subtract the 6. I have 4x equals negative 4. I'm going to divide both sides by 4, and I get that x is equal to negative 1. All right, so we have that x equals 4 and x equals negative 1, so we have to plug it back into the whole thing. So we have the absolute value of 4 plus 6 equals 3 times 4 minus 2. This is the absolute value of 10 equals 3 times 4 is 12. 12 minus 2 is 10, so 10 equals 10, and that's a solution, okay? Now we have to test this one. This is a solution. We're going to plug in negative 1. The absolute value of negative 1 plus 6 equals 3 times negative 1 minus 2. Negative 1 plus 6 is a 5, absolute value of 5. This becomes negative 3 minus 2, which is negative 5. Does the absolute value of 5 equal negative 5? No. Okay? So that can never happen, so this is not a solution. This one only has one solution, x equals 4. So if you, as an answer, you put in, these answers are 4 and negative 1, you would be wrong. The only one that would be correct is if you said the answer is x equals 4. Which is this one. Right, that's the only solution that this system has.